Hey guys, what's up? Eddie Alho here with KissAnalog.com. Hey, I got a video on this transistor tester. It's a low cost little dude. I'm going to put the price right here. I don't remember what it costs. I remember it was kind of low cost, like around 30 bucks it seemed like. But I saw a video on it where you're supposed to be able to just plug in a transistor, whatever, MOSFET, BJT, thyristor, and it'll tell you what it is. So I thought that was pretty cool because I've got some boxes with some parts that I could look them up online, but it'd be really neat for this thing just to tell me if it's PNP or P channel or what. And also if I want to check the gain. So this guy seemed like a good thing to get. So let's do a quick video on this, okay? Now open the box, we're going to play with it and see what it does, right? Let's do it. Okay guys, so this is the transistor tester. Easy to use, there you go. And it's really cool. It has a resistance to discharge your capacitor. Okay, it does ESR. And okay, that's the looks like it measures resistance 0 to 50 megohms, 0.01 ohms. Capacitance 25 picofarad to 100,000 microfarad. That's pretty big. And resolution 1 picofarad. That's kind of hard to believe. Maybe down this range, I don't know. That's these resolutions are pretty amazing. Inductor 0.01 millihenry to 20 henries. Wow, that's crazy. Resolution again 0.01 millihenry. Capacitor ESR resolution 0.01 again. Gosh, those are crazy. It even has a CE mark on it. Okay, there's product description. So I was getting it for diodes and triodes and thyristors, these kind of things, MOSFET, for doing gain. The polarity of the pin. So it tells you what the pins are and the valve voltage, the junction capacitance of the FET. So, but it sounds like it does these other things too, capacitors, inductors, and that. So that's kind of crazy. Wow, seems almost too good to be true, right? Let's look inside here. It's a pretty simple guy. Chinese. There's English. Looks like it repeats the specs are on the box. Okay, so pretty simple instruction manual. Alright, looks like you discharge it on this side and measure it on this side, I think. And it has surface mount measuring capabilities too. I thought it was kind of cool. There's some programmability, it looks like, as well. It says it's got a frequency generator. We'll have to check that out. It's got a bunch of stuff. 10-bit PWM, C plus ESR, rotary encoder, self-test. Let's put that aside, and we don't have to rip it open. We can just pull it right out. Little tweezers here. Oh, I see a plus symbol. Alright, that's cool. Wow, look at that. So it's like a coax cable going into the probe, and the little banana jacks out here, the little protector boots on them. That's nice. Keeps them from getting squashed. That minus side is hard to see, but I see the plus over here. But now I know what I'm looking for. I can see the minus. So yeah. I wonder if it'll measure parts in circuit. That might be too much to ask, maybe. But, huh. Okay, nothing in there. Alright, so here, let's get rid of that. There we go. It's the BSIDE ESR02 Pro. Okay, so it looks like this is where you do the surface mount stuff, and here's the range right here, 0 to 50 megohms, so that's nice. It repeats it there. Capacitance inductor. Discharge resistance, max 2000 microfarad, 50 volts. So you don't want to put more than 50 volts or bigger than a 2000 mic cap to discharge here. So I think that's just a resistor, 1 k ohm, 1 watt resistor in there. And so then you measure over here, and I don't know if there's a polarity on this. I don't see any polarity. I don't think there's supposed to be. I think it's supposed to just tell you what it is. Transistor tester up here. It says the BSIDE ESR02 Pro. Okay, there's a, oh, that's cool. It didn't come with the power source, but it says DC 9 to 12 volts. Aha! I got a battery. Hold on. Okay. That'll work. And what is this? Typical ESR value of electrolytic capacitors. So, okay, it's hard to read. It's voltage across here, capacitance down here, and then a table of typical ESR values, I guess. So I guess this is just a, so here, let me see if I can get close. So I think this is showing you typical values, and maybe when you measure it, it looks, you can kind of compare it to this table, see if you're in the ballpark. There's that CE mark. Alright, then we recalibrate. Okay, so here, I'm going to get a battery in this, and I'm going to get some parts, and let's just do that real quick. And then I'll get some parts to test. And there we go, I think. Cool. It says power test, 20-second auto off. It looks like they're, okay, no unknown, wait. Okay, there's a backlight there too. Might not be able to see that with my lights. I'll turn off the lights for a minute. Turn off the lights. Whoops. Yeah, so there you go, backlight. Okay guys, so I picked out some random parts here. I'm mostly interested in these things, but let's start with just these passive parts. It says 25 picofarad, so I got a small cap because I think that maybe the smaller values are going to be the ones that it'll be the most difficult to have high accuracy, I think, for these small parts. I'll try to stick it in there. These leads are so flimsy. Alright, hold on, I got a helper here. I'm going to try to separate them with these. Wow, those jaws are pretty strong, and these leads are really flimsy. So, really hard to stick in there. I was spinning the crap out of them. Alright, so let's just see what that does. Okay, battery 8.4 volts, okay, 61 picofarad. It's supposed to be 68, so, you know, well, hold on a sec. Let's see, we can compare it to a real meter. There we go. I was going to say, I don't know how to see if that accuracy was on target or not. Okay, here, let's stick it in here. Man, same thing, these leads are so difficult. Yeah, I don't know if I don't want to use these long leads right now. I want to try to stick it in here. Oh, there we go. There we go, 63 picofarad, 63.1. Now this, you can measure different frequencies, so that's at 1 kilohertz, that's kind of a normal, 63. Okay, 62.9, that's a 10K, that's a 100K, 63, 100K, back down to 100 hertz, 63, 120, wow, 120, that's funny, it's that far. And 63. Wow, that's funny that 120 hertz was that far off. Let's see, 1 and 3. I wonder if I can touch these two surface mount guys. Try not to touch leads. Wow. Yeah, you know, 64. So pretty darn close to this guy. Alright, I'm a believer. I think that it's reading the small range stuff. Well, we'll keep this here for a minute. I think. Yeah, you know what? Let's go with a big, well, before we do that, big capacitor. Wait, I got another capacitor over here. Hold on a sec. I've got a couple capacitors. Okay, now I'm a little afraid of these aluminum electrolytics actually. So, you know what, before I stick one of those in there, I don't know the polarity of this thing. I'm a little bit nervous putting a polarized capacitor in something I don't know anything about. It doesn't have a polarity on these terminals, and I didn't see anything in the paper over there. I think it's supposed to not matter, but I'm going to put another poly cap in here. Jeez, I'll tell you what, it's not easy to do this. These terminals are so stiff. There we go. There we go. That's not so bad. Alright, cool. Alright, I'm going to put the scope on it. Hold on a sec, I'll be right back. Okay guys, so I've got the scope hooked up, and I've got this at 500 milliseconds per division, so it's in roll mode. I go a little bit faster, I think. I just want to go in this mode here because I don't have any, I don't know what's going to happen here, so I want to see if I can just, I read the manual, it says it does 5 volt function generator, so I'm assuming it can put out 5 volts, so that's 2 volts per, so that's 2, 4, 6, 8. So I should be able to capture things here. And let me see, on the trigger, I've got it on this alternate, so it'll trigger on either rising or falling. So we can capture whatever happens. Okay, everything else, edge trigger, DC coupling, source is channel 1 right here. Alright, let's do it. Let's put it in roll mode. Okay, rolling. So I'm going to go ahead and hit the thing and see what happens. Whoa, okay. It's going up and down. Okay, so we want to capture that. So I'm going to do single. Okay, so I've got, I put this in single mode so that we can, it's still rolling. That is funny. Here, let's try this. Okay, so the single, oh, it did capture. Okay, that was interesting because it was rolling, but yet normally when I go in single, I don't expect anything to happen until it captures a signal, but it was in roll, so that was interesting that it did that. Okay, now you notice there's a line plus all this stuff. Sometimes there's artifact left over. I've seen this on the more expensive scopes too. Oh, it looks like I haven't captured everything. But what happens with that is, if I notice on this Tektronix, this real expensive scope I use does that sometimes. I think what that refresh rate, I think it leaves the one on the screen, and then and then after you stop it, it puts one last one on top of the other one. It's just an artifact, I think, that's left over. It's kind of annoying, but anyway, I notice it does on the expensive scopes too. Okay, well, it looks like it's testing going both up and down, so I'm gonna have, and there's some stuff going over here, so I need to go a little bit more time so I can capture more stuff. Okay, let's go in single mode and hit that again. There's a couple of notches like this one. One of them went off screen. Yeah, so I don't think I'm capturing everything still, so let's go out one more time. Single level, that's 500 milliseconds per division. It was 200 just before. Alright, there we go. It looks like maybe I did wow, does it? It looked like I did capture everything. There's a little notch there, and then there's a bunch of stuff here. So we can zoom in on this stuff. Now I can zoom in that way, or I can use the zoom feature. Whoops, there we go. Now I push this. Oh, you know what? I don't think I can use it because it's in roll. You have to turn off the roll mode. Actually, I want to turn that off anyway. Let's turn that off. Come on, single capture, slow acquisition, it says. It's because of the 500 millisecond. Now it says ready up here, so I think we're ready to go. says slow acquisition. I know you can't see that. I'm zoomed out. I'm zoomed out so you can kind of see what I'm doing here. Let me try to get a better zoom here. Okay guys, I obviously zoomed into the screen so you can see a little better. So let's zoom in on that. So that little slice is this little thing right here, right in the middle of the screen. Let me spread that out. There we go. See that dark spot? Now I'll move that over. So it looks like it's putting these little signals out to try to measure the capacitance. It looks like it charges the cap real quick and then it discharges, and then it goes to 0 and then it, that's interesting. Charges very quickly, at least in this, we're at 20 milliseconds zoomed in, at least as far as 20 milliseconds it looks fast, and then it discharges. I think this is where it's measuring the capacitance, is this discharge rate. And they might be measuring ESR during this turn on, or this, yeah, to see how fast they can turn on maybe. Let's scroll across and look at a little bit more. And then, yeah, so it turns on fast, there's a little discharge and it turns off. So once it gets its measurement, it probably just turns on, it turns on a transistor or something, discharges quickly. Yeah, it's interesting what's going on. I think this is probably ESR measurements, these sharp edges. Because I don't see it as a frequency kind of test. It looks more like random stuff. Then, yeah, there's this little thing. Yeah, so I think it's trying to get an ESR measurement, and then goes back to this kind of thing. That's kind of interesting, but I guess the one thing I was worried about was putting a DC charge on it, but it's an AC waveform, so I don't think we have to worry about it with the polarized capacitor. But that is kind of crazy how that's measuring the value. Alright, so let's go back to looking at the meter. Alright, now let's see what it's telling us here on the display again. Honestly, I wasn't even paying that much attention. 10.31 mega ohm. What the heck? Thinks it's a resistor? I don't know why there's two different buttons. Okay, you know what? I'm kind of wondering if this capacitor is actually just charged up, and I don't want to pull those leads out because it's kind of a pain in the butt. Oh, you know what? I wonder if it's measuring the 10 mega ohms of my probe. Oh my heck. Let me disconnect the probe. Yeah, there we go. Wow. So it's 1126 picofarads. So that's like 1.1 nanofarad. That is crazy. So that capacitance is so small, and there's a capacitor in the probe as well. I guess it was trying to decide what it was measuring, and it thought it was measuring a resistor. So what we saw in the oscilloscope, that's probably why we saw those weird waveforms, because it was trying to decide what kind of part it was. Alright, let's try measuring something a little bit bigger. I'm going to short out these leads, make sure it's discharged. Okay, let's go to, I'm going to just stick the plus lead in pin 1. I don't think it matters. Okay, this is a bigger capacitor, so I'm going to, okay, here, let's just test it first. I don't want that thing blowing up in my face, so. Alright, well, shows it's a capacitor. It's 235 microfarad. ESR is 0.21 ohm. And V loss is 2.7. Okay, so You know what? I am going to put a probe on this one more time. Put negative to negative of the capacitor. I just want to see if the bigger capacitor, if the screen looks different. Here, let me zoom up to the screen. Okay, I'm going to hit that single mode and try it again. I just pushed the button. It says it triggered. Oh, there you go. Alright, so that's a different waveform. Here, let's turn off the zoom. Alright, there we go. That's different. Now it's triggering here in the center of the screen right here, so I'm going to move the trigger over here to see if we're missing something. Let's do that one more time. I moved it. Whoa. Sometimes this scope gets so jumpy. Whoa. It's 500 milliseconds per division, and you know, again, the Tektronix at work, when I'm at, see, I'm at 14 megapoints. When I'm at deep memory on the scope at work, it does that sometimes too. It jumps around, and it's kind of irritating, but I don't notice it near as much on the Siglin, actually. Okay, here we go. Single trace. Here we go again. Boom. Hit the button. Okay, guys, I tried to get the lighting in focus better. Okay, that's the test waveform. That makes sense to me. It's charging the capacitor, and that's how it's reading it. And then it discharges it. See a little notch right there? Discharges it, and then charges this side. So I think during these charge cycles is when it gets capacitance measurement. And then this discharge rate, I think these fast ramps are for ESR. And then there's this little clocking thing here, so that could be, I don't know. I don't know where it's reading ESR, but I imagine this charging phase is capacitance reading. Pretty interesting. Okay, again, I just hit the button. Again, on the screen, 233 microfarads, 0.22 ohms, okay? Let's try it on this LCR meter. It's a little bit of a glare there. Okay, just discharge capacitor. Just short the leads together to discharge it. And stick it in here. Jeez. There we go. I think I got him in there. It's an auto LCR meter, as it says. Okay, 201 microfarads, 0.58 ohms. That's a 1 kilohertz. Let's check it out. 100 kilohertz. Yeah, that's all the way up to 4 ohms. So this is 10 kilohertz. So 10 kilohertz, yeah, 4 ohms. So this is not a capacitor you'd want in a high frequency filtering. I don't think I have a very good connection here. Alright, I think I got a better connection. 195, 1.7 ohms. That's a 10K. 100K, 3.5, and boy, it changed the resistance. So this guy's starting, that's 3.5 degrees. So this guy starting to look more like a resistor than a capacitor at 100K. So, not a good capacitor for high frequency stuff. Okay, that's 100 hertz, and we're at 0.1 ohm and 250 microfarads. So yeah, if you really need to know a capacitor, one of these guys is what you want. This is pretty nice though, just to get a quick measurement though. Okay, let's go on. Let's go on to the fun stuff. I want to get to transistors and that. I was going to do that big cap, but I think we got the idea of the capacitors, right? Heck, let's just do a big one real quick just to see. Wow. Can I get them in there? Kind of curious what it's going to do with that big cap. 0.06 ohms. So it thinks it's a resistor. Alright, well, maybe it looks like a resistor. This is a pretty decent cap though, 0.06 ohms. Oh, shoot, sorry, I had a short circuit there. One of my little, that's the problem with stranded wires. If you're not careful, you'll get a short. So, it wasn't a very good short, huh? 0.06 ohms. Okay, try to keep those shorts from happening. Let's try it again. Here we go. It says testing C, so 6600 microfarads, 6670, 0.07 ohms. So, and it's supposed to be 6800. So, yep, that sounds good. All right, let's just do the one low frequency measurement on this guy. This guy is polarized, so I'm going to short this to make sure. Okay, stick it in there, stick that in there. Okay, here we go. .43 millifarads, 0.17 ohms. Okay, forget that guy. Okay, so the fun stuff. We did capacitors. Okay, we'll do a I had a resistor, but I'm not gonna bother with that right now. Let's try a diode. I had some loose diodes on another thing I was doing. This should be easy to plug in here. Big old fat leads. Alright, let's try that. Okay, UF, so that's voltage forward, 614 millivolts. That's kind of what I expect. Something like that. Reverse current's 4 nanoamps, and it has 55 picofarad junction capacitance. And it shows the anodes pin 1 and cathodes pin 3, so that's pretty darn cool. Stripes on pin 3, so alright, so diodes are no problem at all. Let's get to big transistor. Well, relative to the little signal transistor down there. This is a power transistor, has a power tap. I'm just going to stick it in there and push button. Okay, so that's really cool. Pins 1, 2, and 3 shows 1 is base, 2 is collector, and 3 is emitter. NPN, and a gain of 54. It's a power diode, so that sounds about right. And forward voltage drop is 1.27. That's a little higher than I would have thought, but I believe it. I almost wonder if that was a Darlington with 1.27, but yeah, a little higher than I thought it would be. Okay, so this is a little signal transistor, just a little guy. It's a 2N3906. Let me separate the leads. Alright, there we go. Let's try it. Okay, PNP, and 1, 2, 3 is emitter base collector. Wow, and it's pretty cool. Oh, gain is 346. These little small transistors have a lot higher gain, so that's cool. Alright, nice. Yeah, that's pretty neat that it can figure it out that what it is so quickly. Yeah, so I heard about these meters, how they were like these automatic testers, and I just thought it'd be really handy to have one on the bench, especially as inexpensive as it is. Okay, now this guy is a FQP 30N06. Stick that in there. Hey, you know what? I'm going to try something. Battery test. Okay, so capacitance 1.73 nano. VT, voltage threshold, I guess is 2.1. And voltage forward 593. Okay, so that's the body diode, pin 3 to 2 is 0.593, and it's a NE MOS. So that's cool. It's an, whoops. So it's an NMOS, and it kind of shows the arrow going into the gate, and 1, 2, 3 is gate drain source. Okay, there's a little diode symbol there on the end. So maybe that just signifies there's a body diode, but it shows it in the picture too. Okay, you know what? I want to flip around and see if it fools it. Alright, looks like kind of the same measurement. So, okay, so the one thing I haven't tested yet, I just realized I haven't tested this guy. And I think the red, yeah, I think the red one goes in pin 2. I'm going to go check the manual real quick. Okay, it says that C plus ESR used test points 1 and 3, so these two. I guess it's the same as 1 and 3 here. So I'm going to do that, and I'm going to just test this big cap here for ESR. I'll try to squeeze those leads together. Well, it's kind of hard. Okay, there we go. Push button. Okay, 458 millivolts. That's weird. It shows it's a diode. I'm going to switch. Well, here, let me short it out. Okay, I'm going to switch the leads now that I've shorted it out and try it again. I wonder if it is polarized. Oh, well, this had a plus minus. I just don't get. Oh, I think I know. Let's try that again. Wow. Okay. So 970. So okay, 975.3 microfarads and 3.2 ohms. 0.32 ohms. And V loss is 1.4%. So, yeah, I don't know. Alright, so I'm going to try this a couple times. I might take it off camera and come back with you. I'm going to just see how this thing works. Shoot. Okay, that read the capacitor. Now I'm going to put I swung around and put it on opposite leads. Alright, it doesn't matter. I think maybe I was touching a lead or something. Okay, there's another feature on this that's pretty cool, and you're supposed to hold this down. Oops. Okay, maybe you turn it on, then you hold it down, and then it goes into this selection mode. So you can choose different kinds of measurements, and you can set it up for frequency. So maybe you can measure capacitors at different frequencies. Here, let's go. I'm going to just toggle through these real quick. You can see all these. I don't have time to go through all these, I don't think. We don't want to make the video too long, I don't think. Here, I'll hold it down frequency. Okay, 0 hertz. I don't get it. Select it. These buttons say they do the same thing. It's for left and right hand people is what I read in the manual. Boy, okay. Maybe I don't hold it down so long. I'm going to just touch it. Wow. I don't understand the frequency thing. Okay. I don't understand the frequency thing. Maybe this one doesn't have that option. Let's see what generator does. Okay. We got different frequencies. Alright, now this one, it said to use pin 2 for the plus. Well, it didn't really say plus, it said use for signal, I think, and then use one of these two for the other one. So I take that as plus. I'm going to hook the scope up to this probe, and then I'll toggle through these different frequencies. Like, okay, you hold it down for just a, there you go. Okay, I'm going to toggle through these things, and we're going to look on the scope to see what's going on. Okay guys, so I just push this up against here so you can kind of watch it. I've got the scope probe on this little tip right here. You can see that. I'm just going to place that there. And I'm going to go through the frequencies and see what happens up here. We're going to have to be, well here, let's just start off. I'm going to put this in auto mode, the scope. And turn that on, and I hold this down, I think. Oh shoot. Okay, now I hold it down. There we go. It did something up here. Okay, so let's toggle down to the generator. I want to see what it does on the generator. So let's hold that down. Okay, 1000 hertz is where it starts off at. So let's, whoa, there we go. Okay. That's okay. Oh, okay, 1000 hertz. Jeez, that's megahertz, right? Okay. Oh, I've got the triggering on alternate, so let's go to one of them, rising edge. Okay, I'm going to push this trigger position in the center of the screen. Okay, see the arrow? So it's triggering rising edge right there. And this arrow is the level. So it's triggering right there. Alright, so that doesn't look like a terrific wave shape, but you know, hey, it's a megahertz from a little inexpensive dude like that. That's not too bad. Looks like it goes 2 meg. Let's try that. Alright. Even looks worse, but hey, I guess, you know, you may not have a square wave, but you got something there. Now this is interesting, 1000 millihenries, or millihertz, 1000 millihertz, that's interesting. So that's like 1 hertz, right? Okay, let's try that. Whoa, look at the toggle. Okay, change it to 200 micro. You go down to 500 mils. There we go, it's in roll mode. I'm going to freeze it. I'm going to turn off roll. Hit a single trigger. Okay. Let's see. 200 milliseconds per division. 1, 2, 3, 4, 5 divisions. They're nice straight edges, so it does 1 hertz nicely. Let's go to the next one. I'm going to go back to auto. 10 hertz. Look at that. 1 hertz to 10 hertz. That's kind of cool. Okay, let's go to 50 hertz. So it's like 50, you know, it looks like each time it's 50% duty cycle. Whoops. Yeah, well, I guess you get the idea. It looks pretty nice. Now, this is 2 volts per division, by the way. Okay, we're back to 1 kilohertz. Or 1 megahertz. Geez, it starts off at 1 meg. It starts off at such a high frequency. I think you give it a little bit shorter of a touch. I'm hitting it too long. But you can't do it too quick either. Wow, look at that. It has all these incremental frequencies. If you guys know what those are for, I'd like to know. I wonder why it does that. And 1000 hertz. There we go. Just looking at this edge, that doesn't look too bad. 2500, 5K. Then we go to 10K. Alright, well, that's pretty cool. Whoops, oh well. Yeah, you hold it too long, it kicks it out. God, you hold it too short, it doesn't do it. So you gotta, you just have to, you know, play with it a little bit. But, you know, for how inexpensive this is, I thought it was definitely worth having on the bench. So, pretty cool little meter, right? Wonder what these little cavities are. Hold your surface mount parts. Hey guys, thanks for watching. If you like the video, if you like this little guy, you want to know more about it, you want to see me do something with it, I'm sure there'll be videos to come where I'll be using it to measure some gain on transistors and that. So we'll see in videos to come, okay? Hey, thumbs up guys if you like this, okay? Appreciate it. See you next time.